Viruses are everywhere. They are tiny infectious agents. Viruses infect all life forms. Even bacteria have viruses that infect them, called bacteriophages. Viruses are masters of disguise. They can change and evolve rapidly. This makes them a constant threat to human health. The common cold is a familiar foe. We know the symptoms well. Runny nose, sore throat, cough. Most colds are mild. We recover quickly. But what if a cold virus were to mutate? What if it became more contagious? What if it caused more serious illness? This is not science fiction. This is a real possibility. We must take viruses seriously. We must understand how they work. We must be prepared for the possibility of a pandemic. Imagine a sneeze. Invisible droplets are launched into the air. Inside these droplets are cold viruses. These viruses are on a mission to find a new host. The virus enters your body. It travels through your nose or mouth. It reaches the cells lining your respiratory system. The virus attaches itself to a cell. It injects its genetic material into the cell. The virus hijacks the cell's machinery. It forces the cell to make copies of itself. Soon the cell is bursting with new viruses. These viruses are released to infect more cells. The cycle repeats. Viruses are constantly changing. They evolve through a process called mutation. Mutations are random changes in the virus's genetic code. Most mutations are harmless. Some mutations can make the virus more dangerous. A virus can become more contagious. It can spread more easily from person to person. A virus can become more deadly. It can cause more serious illness or even death. A virus can become resistant to drugs. This makes it harder to treat. Viral evolution is a major threat to human health. It is why we see new viruses emerge. It is why we see old viruses reappear in new forms. Scientists around the world are working to understand viruses. They are studying how viruses spread. They are studying how viruses evolve. They are developing new ways to prevent and treat viral infections. One important tool is genetic sequencing. Scientists can now rapidly sequence the genome of a virus. This allows them to track mutations in real time. It allows them to identify new variants of concern. Scientists are also developing new vaccines and antivirals. Vaccines help our bodies develop immunity to viruses. Antivirals can help to treat viral infections. Section 5, Shielding Humanity, Preventive Measures Against Pandemic Threats. We cannot prevent viral mutations, but, we can take steps to protect ourselves from pandemic threats. We can practice good hygiene, wash your hands frequently, cover your mouth and nose when you cough or sneeze. We can get vaccinated. Vaccines are one of the most effective ways to prevent the spread of infectious diseases. We can stay informed, pay attention to public health advisories, be aware of the symptoms of viral infections. We can support scientific research. Funding for viral research is essential. It allows scientists to develop new tools to fight viral threats. Section 6, The Power of Knowledge, Staying Ahead of the Curve. Knowledge is power. The more we understand about viruses, the better equipped we are to deal with them. We need to invest in science education. We need to promote scientific literacy. We need to be critical consumers of information. There is a lot of misinformation about viruses circulating online. Get your information from trusted sources like the World Health Organization or the Centers for Disease Control and Prevention. Section 7, The Importance of Global Cooperation. Viruses do not respect borders. A viral outbreak anywhere is a threat to everyone, everywhere. We need to strengthen global health security. We need to work together to detect, track and respond to viral threats. We need to share information and resources. Countries need to work together to develop and distribute vaccines and antivirals. We need to build a global health infrastructure that is prepared to handle future pandemics. Section 8. The role of technology in pandemic preparedness. Technology plays a crucial role in pandemic preparedness. We need to invest in new technologies to improve surveillance, diagnostics, and treatment. Artificial intelligence and machine learning can be used to analyze large data sets and identify potential outbreaks early on. Telemedicine can be used to provide remote healthcare services, reducing the burden on healthcare systems. Mobile health technologies can be used to track symptoms, provide health education, and connect people with healthcare providers. Section 9. The future of virus control. The fight against viruses is a never-ending battle. As viruses evolve, so too must our strategies for controlling them. We need to invest in basic research to understand the fundamental biology of viruses. We need to develop new and innovative approaches to vaccine and antiviral development. We need to strengthen our public health infrastructure and improve our ability to respond quickly and effectively to outbreaks. The future of virus control depends on our continued commitment to scientific research, global cooperation, and public health preparedness.